you guys are good looking. I don't know if you've heard that today, but it's true. Man, I even have my glasses on. Without them, even better looking. No kidding. Anyway, um, hey, this video we're going to be talking about algebraic fractions. We're going to be talking about multiplication. I wanted to do add, subtract, multiply, divide all in one video, but as I started looking at the examples and some of the things that come up that are tricky, I decided it'd be smarter, maybe better for you, if we separate them into several videos. So we're going to do multiplication in this one and probably division as a separate one because there are some tricky things that occur when you start dividing. So anyway, let's switch over to the document camera and let's get started, shall we? So with multiplication, right? With multiplication, you know that when you're multiplying fractions, you multiply the numerator, you multiply the denominator, easy peasy lemon squeezy, right? But, and this is super, super important. The more complicated the expressions you're dealing with become, the more important it is that your fundamentals are solid because you end up creating bigger problems if you don't, have your routines down. So one of the things we want to do, we want to make sure that if you're dealing with algebraic fractions and you're going to be multiplying, if you're going to be dealing with algebraic fractions, you're going to be multiplying, that you have to RBM. That means reduce before multiplying. Reduce before multiply. Multiply. Yeah. So anyway, really, really important. Let's take a look. On this one right here, if you don't reduce first and you just multiply right across, you're going to have 6 over, let's see, 72. Wow. First of all, 4 times 18, that's kind of a tricky one, right? That is not done. It has to be reduced. When you reduce, what you end up doing is end up factoring. Factoring is on multiplying. So to reduce in your head, you just say, hey, what goes into 6? And is there a number that also goes into 72? And you'd end up saying, oh, well, that's 6 times 1. And that's 6 times 12, so it's going to be 1/12. Do you see how you unmultiply this to get your reduced answer? Well, why not just reduce at the very beginning, because it's going to be a whole lot easier. See, look, we could reduce 2 over 18, that's 1/6, or we could reduce this too if we wanted first, because look, 3 and 18 can be reduced, and 2 and 4 can be reduced. And the reason we can do that is because we're multiplying. When you're multiplying, you can change the order, right? So like, I'll show you how to do it first, and I'll show you why it works second. So look, first of all, 3 goes into 3 one time. So we divided that by 3. 3 goes into 18 6 times, right? 2 goes into 2 one time, 2 goes into 4 two times. So we end up with 1 over 12. You see? 1 over 12 is what we found here. Now the reason that we can do that, that's a shortcut we just did right there, where we reduced across. The reason we can do that is because you can rearrange the order when you multiply. Or, so like, for example, this is 3 times 2. These two things are the same. Would you agree? Those two things are the same because you multiply the numerators, you multiply the denominators. So 3 times 2. Now would you agree 18 is 3 times 6 and 4 is 2 times 2? See, we switched those two. 3 divided by 3 is 1. 2 divided by 2 is 1. That's 1 over 12. Do you see? We never write it out that way because that takes a little longer. But that's really what's happening right there. We're using the commutative property of multiplication, and then we're using the idea that a number divided by itself is 1, and you don't need to write times 1 times 1 times 1. You don't need to write that, right? So that's really what's happening right there. So it's always important that before you end up multiplying, that you go ahead and you reduce completely and fully and all the way, right? So let's go through a couple of examples right here, shall we? We got room right here. Let's do one right here. Let's do 54x cubed over x cubed minus x times 6x over 9x cubed. Now, boy, there's a lot of things I see on here that can be reduced. So before we even get into it, let's take a little time to think about this and talk about it. And I would suggest that if you're taking a test and you see something like this, you might go, oh my gosh, that's overwhelming. Might be a good idea to just give yourself, say, 10, 15 seconds, whatever, just to be patient, to look at it and see if you can find any common factors, right? So like here, there's an x cubed. This has an x cubed and this has an x. So this is reducible. I can reduce this entire fraction right here by x if I wanted. Over here I've got a 6 and I've got a 9. They're both reducible by 3. Oh, when I do that, that's going to be 2. That's going to be 3. 3 goes into 54. I know that because 4 plus 5 is 9. That's the shortcut for 3's, right? If you can add the digits and your sum is divisible by 3, then the entire number was the original number was divisible by 3 as well. So anyway, and then this x and that x, the x cubes, those are reducible. So here's what I would do. If I was doing this problem on my own, here's what I would do. I would say, okay, well, x cubed and x cubed, those can be reduced. But be careful, this x cubed and that x cubed cannot, because this is one number. If I were going to reduce this way, it would look a little different. I'll show you how that looks next, okay? All right, now, this right here is really, well, I don't know where to write it. If I had a pencil, if I was writing with pencil, which would be hard to see, here's what I would just put a little, I would cross it out and write like this right here. Do you see? Would you guys agree that this x cubed minus x is the same as x minus x squared minus 1? Sorry, x times x squared minus 1. So look, the reason I did that is because these x's are reduced. Now, 6 and 9, or I could do 9 into 54, because 9 goes into 54 6 times. So here's what I got now, right? I got 6 times 6 over, this reduced to x squared minus 1, oh, times 1. That's it. So I got 36 over x squared minus 1. That's it. We're done. All the way simplified. There's not a common factor between all the terms, so we are done. Let's look at it a different way. Same problem, different way. Let's say we had a different approach. And the reason I want to show you this is because it's not like one is better than the other. One approach is better than the other. It's not like that at all. It's more like what you see that's easy to do is how you should try it. You should be smart about it. You should think about it, but you know. So here's probably how I would have done this problem if it was me doing it on my own. I would probably say, I'd probably do it like this right here. I'd probably just write the fraction. I would probably say, look, well, this is a cube right here, I'm sorry. I would probably say, well, I can reduce this whole thing right here by x. So I'm going to have 54x squared over x squared minus 1. And then times, and then I would reduce this by x and by 3, right? So this is going to be 2 over 3x squared. Do you see? I multiply by, I divide by 2, by 3, I get 2 and 3. And x cubed, well, this would just be times 1, and that's x squared, right? So then I would probably, what I would do next, I'd say, oh, well, 3 goes into 54. Let's see, just to make sure, right? Just to make sure. You could probably do it in your head, but, you know, this works right here, right? 3, 24, oh, look at that, 18. Isn't that beautiful? So we got 18, and the x squared reduces. 2 times 18 is 36, x squared minus 1. Pro tip right here also, if you were doing a quiz or a test, you got a little extra time at the end, stuff like this, try a different method, see if you get the same answer, because if you do, you probably got it right to begin with, right? All right, now, let's try one more example right here. Nice thing, excuse me, can't cough right now with the coronavirus going on. I mean, here's the date, 3/19/2020. That's the date of recording of this, right? So right now, at home, doing giving students learning opportunities, and so it's kind of funny. Not good. Don't mean to make light. It's a very serious situation, but man, don't cough. Anyway, so this one right here. Nice thing about multiplying algebraic fractions, I was saying, is that you do not have to find a common denominator, and so in some ways it's a lot easier. But you do absolutely want to reduce first. So like, for example, here 7, right? And 14. Well, that's 1 and that's 2. 7 goes into 7 one time, 7 goes into 14 two times, done. Oh, wow. Would you guys agree that x minus 1 squared is x minus 1 times x minus 1? X minus 1 times x minus 1. Look at this. They reduce. So your final answer looks like it's just 3 over 2. Wow. Not too bad, right? So reduce before you multiply. Life's easy. Um, give you a couple practice problems right here, shall we? Let's do. Let's try this right here. Let's try 16 x squared minus 4x over x squared minus 2x minus 15 times x minus 3 and then over 8. Let's try that. And then let's see, come up with another one right here. Let's do 5x over 15b times b over 3x. Try those two. If you're in my class, you can, of course, send me an email. You can put a message in the Google Classroom. You can also leave a comment in down below with your answer or a question. I'd be very happy to help you out. Hey, let me know if you do have questions, comments, concerns, gripes, complaints, whatever. Be happy to hear from you. Hope all is well. Hope to see you all soon. Have a great day.